So what we've got today is a 2001 or a window regulator 2001 Honda Accord, and basically the way this works, this is the rear window regulator, one of them. The way this works is the window is captured in the door. It bolts, the bottom of the window bolts in here. This motor turns, right, and moves this arm back and forth. And as this moves back and forth, it shoves the window up or pulls it down, right? So that's about all that's going on. Fairly simple. Expecting this just to be a brushed DC motor. Two screws holding the motor into the gearbox here. Oh, wow. Okay. So here's the housing. We've got two laminations that are epoxied in. You can see just a little bit of epoxy on the back side there. Held in place or centered by these two springs. In the back, we have a oil-lite brass or bronze bushing that sits back there that the shaft runs on. Interesting. Got a moisture seal sitting on top there. And now to get the gearbox the rest of the way apart is going to require some creativity. So what typically goes wrong with these things is the brushes, which must be further in there. The brushes typically kind of wear out, or the commutator gets dirty, which is this guy right here. And it just stops making power as that happens. It's kind of a slow progressive process. The resistance goes up, and of course as resistance goes up, you get less power through the motor. More power is being burned trying to just overcome that resistance in the motor. And at some point the window just won't go up because the motor just doesn't have enough torque to do it. All right, that's finally apart. Okay, so the sheet metal portion of it, it's highly magnetized. So you can see this arm just moves back and forth. We've got a pinion that sits right here. Wow, that's pretty greasy. Pinion that comes up here and faces on the gear, or meshes with the gear there, and moves back and forth. And you can see, you can see that thing slightly turning. Gear ratio is going to be, pretty serious gear reduction to get that to spin. Probably, I wouldn't be surprised if it's 100 to 1 to get that to go. So now we got to pop this body apart here to get in. All right, so that back cover is just glued on. Looks like it's got a bead of silicone for moisture sealing. The back end of that bushing looks like it's got some moly grease, that black grease back there. Yeah, it looks like that shaft is just riding in the housing. So this little shaft here is just riding in this. It looks like that yellow zinc, probably just a steel part. Yeah, just punched steel is all it is with that yellow zinc coating. So that's kind of interesting. No bushing of any sort to speak of. So we got a little snap ring holding in this guy. I'm guessing we're going to have a worm and wheel is going to be the setup here to make that spin. Let's see if we can get these brushes out. All right, so there's the worm for the off the motor there. It's kind of interesting. They run the shaft off the back side of the motor. So the brushes are here, and these appear to be pretty severely worn. Let me see if I can show you this. Just bend them up here. So yeah, you can see Well, they're actually designed to wear in and get a larger contact pattern as they go. That's kind of interesting. So you can see the brush material is kind of tapered on there. It's in a wedge shape. But you can see that all it was making contact with on the commutator is this little area. And it looks like what they were trying to do is have this, as it wears, hit a larger and larger area on the commutator. So that you could basically wear in. Because what happens is dust and the graphite and everything accumulates on here, and eventually this just stops making good contact, or it kind of pits a little bit, and the brushes just, on one of the commutators or several of the commutators will just not make good contact. So you'll end up with a dead spot in the motor, or like I said before, the motor just gets weak over time. So that's that. This appears to be cut on a lathe, and it also kind of looks like it might be hardened. I don't know if I have a file out here or not. Nah, it's fairly soft. Yeah, it's 40 Rockwell file, and it is biting in there pretty good. So, never mind, not hardened. Disregard. What threw me for a loop there was this this mark here kind of looked like a heat treat marking here, but I think that's just the rubbing from the bearing on there. So we got a little snap ring on the back, and it's a little tiny one, so we might have to just go straight to the reverse action. All right, so we've got the gear, which is keyed into the, we've got the pinion that actually moves up and down the window. Appears to be a sintered metal part, and it appears to all be one piece. We've got a thrust washer on the back here, just to provide some riding. Yeah, so the gear itself looks like it is sintered metal, but it looks like this portion has been turned. Turned on a lathe. And these faces appear to be part of the sintering process. So this whole piece would be sintered with these little dogs on here. This body's going to be turned just to make it nice and concentric and nice and smooth. And then the rest of these features, including this guy back here for the what I'm going to guess is a bushing. And the rest of it's all just sintered metal. So in here, we've got a nylon wheel as part of the worm and wheel assembly. It is attached, that's interesting. So it is attached to the dog on there by this rubber bushing. So this is kind of like a harmonic, the thing on the front of the engine, dampener, harmonic, something. It'll come to me eventually. Harmonic balancer. Yeah, harmonic balancer. So these dogs ride in here, and this is just going to provide it with some cushioning to absorb any shock that would go into the gear as it goes. You can see that this nylon gear is hobbed by the fact that these teeth... Oh, did I speak too soon? No. So you can see that the cutter left a rise. So this is curved up. I don't know if you can see this or not, but the end of the tooth is curved up. I don't know if you can kind of see the screwdriver kind of scooting up. So this would have been hobbed on something to give it that kind of sideways tooth pattern. And they've got the curved pieces up here, I'm guessing to kind of add some strength, because you've got this outside... as opposed to this being just gear teeth all the way across, you've got a solid piece here, which is going to provide each of these teeth with more strength as this goes. So that's what's going on there. So that's it. I think we've got a here just past these brushes. We've got an oilite bronze bushing, which is what this shaft is going to be riding on. I'm guessing in the far end here, there's going to be another one of them. I don't know if I can get that out. Let me see. Yeah, I can't get in there too easily, but very likely in this end there's another, oh, yeah, you can kind of see it here. There's another bronze, oilite bronze bushing that holds the far end of that. I'll just drop that. Holds the far end of that shaft. The rotor itself looks like it is the shaft. This is kind of interesting. I don't think I've seen this before. The shaft looks like it's epoxy dip down here. And on the end, this kind of looks like a thrust bushing kind of thing. I'm not entirely sure what that is. That's interesting. I wonder why that's a different color. Maybe like a brazed bronze something. Because obviously this worm and wheel, when it's turning, is going to want to scoot back and forth. So you also need some mitigation on either end to keep this from wanting to go back and forth. So this is the bearing retention feature, and you can see that there's a corresponding spot, kind of thrust bushing type of thing down in there that mates into. Not a whole lot else to say. I mean, this is just that ubiquitous nylon, glass fiber reinforced. This has tons of glass fiber reinforcing in it. I got a couple moisture seals. Here's another one. And that's about it. So, yeah. Of course, you know, forward and reverse would be done just by reversing the leads on this thing. One thing I suppose we could do, I've got another one here. I should have done this before I took it apart. Yeah, my idea was to pop this motor out and rotate the motor by hand and check and see if we can actually see any dead spots on the commutator with a multimeter. But the more I'm thinking about that, the more I think that's not going to work. Just because I would have to leave it in the pinion, and we would be here all freaking day spinning that pinion trying to get this motor to find dead spots. So, yeah, oh, just noticed that. For balancing, looks like they went at it with an angle grinder or something. Kind of carved some slots out there to reduce the weight. But, well, anyway, I think I'm just going to leave that there. So, thanks for watching.